Today we're going to talk about something that's, we have three panel members who are very passionate about and going to bring some energy here at the end of the day talking about, which is kill chains. And what you heard in the video is it's a series of events that come together to some end effect. And there's lots of frameworks to describe it, like observe, orient, decide, and act, OODA loops, find, fix, track, target, engage, assess, F2, T2, EA, several different types of frameworks to describe this. But really what it's getting after is collecting data, turning it into information, and then getting that information to a decision maker on a timely basis. Because there's likely someone on the other side that's doing it just like you, and you want to be ahead of them in that decision making, and that you want that data and decision advantage. So today we're going to hit three parts of what makes kill chains effective. The need for speed, how do we move data quickly, and how do we integrate something that can be challenging, especially when we talk about doing it across systems of systems. And sometimes those systems of systems are not necessarily designed to be integrated seamlessly. So how do we get about that? We're going to talk about how emerging technologies are aiding us as we get after closing gaps in the kill chains. And then we're going to look towards the future on what are we looking at to make sure that as we move to that future state for our nation and for our way of life, we're advancing technology to make sure that those kill chains are going to be ever faster and more effective. But before we get into that, I wanted to hand it over to my colleagues here on the stage to introduce themselves and tell you what they do and how they work on kill chains. So we'll start with Jared.
All right, thanks, Dave. Jared Herwig here. I'm with the Space Systems Integration Office at Space Systems Command out in Los Angeles, El Segundo area. Wasn't that a great video? That video really showcases what we do, what we are passionate about in the Space Systems Integration Office on behalf of the Air Force, advising the SAE, our Senior Acquisition Executive, as well as the PEOs, taking disparate legacy systems and emerging systems that are coming online to enable the Space Force to perform its mission more effectively and cohesively as a single unified fighting force, but not just for space's sake, but also integrating into the joint force, the joint fight. Space does not fight alone, and neither do the other services. So we are in a multi-domain construct. And what's interesting about that video is it really talks about there's no I in team, but I am an integrator. So let me hand it over to Tatum.
Thanks, Jared. So Tatum Poole, I'm from Lockheed Martin. I've had the privilege of supporting a variety of programs across my career. My badge says King of Prussia, but we usually use Valley Forge because it's a more well-known place, and we don't have to explain why there was a king in Pennsylvania years ago. My team is part of what we call a business area under our national security space security and intelligence. So we're bringing together elements of DoD and elements of the IC to make sure data can flow from end to end into those architectures that SSIO is studying and ultimately achieve an effect for the warfighter, right? Get the information to the right decision maker at the right time. So happy to be here. Thanks for the opportunity. Turn it over to my friend from Boeing.
All right, thank you, Tatum. Good afternoon, Paul Pontius with the Boeing Company. I have the privilege of leading a group that works across all of Boeing, the four divisions within Boeing Defense, Space, and Security, where we're really focused on joint warfighter interoperability, working with the various different programs, what we coined the phrase from seafloor to space. Working with the warfighter and our stakeholders so that we can ensure that we're hearing the voice of the customer, that we're focusing on bringing forth the capabilities that are required to be interoperable in a joint construct so that a Boeing system can seamlessly integrate with a system from Lockheed Martin, with Northrop Grumman, with Raytheon, and other industry counterparts led by our government stakeholders. So, thank you.
All right. So the first part, the need for speed and seamless integration. So what we're going to hit on here is why is closing the kill chain harder than ever, and what's standing in the way of faster decision making. So Jared, you're up first. All right.
Try to stump the dummy.
Yeah, here we go. From the operational perspective, where are the delays and breakdowns in the kill chain, and what concerns you the most?
Yeah, so there's multiple perspectives. It depends on where you sit and which problem you're trying to solve. within the collective kill chain right construct. But I've in what I do in trying to bring everybody together, there's really three things that tend to get in the way. Classification, we've heard that earlier today. Being able to share the information both up and down. We have many cross-domain solutions that will allow us to seamlessly send information to higher and higher classification levels, but I end up with, at some point, only the SecDef is fighting the war, and maybe even just the president, or maybe somebody higher. I'm not sure. We haven't quite figured that out, but classification gets in the way, and I need to be able to go back down because we typically fight a war at a secret level. Okay, and data is key, but I get timing. Okay, so there's classification gets in the way. I need timing. I need data to decision, and the way that I buy back my competitive advantage in war is time. Okay, and then finally sensing. Space is an austere environment. I don't need to convince anybody here of that. But we are a remote force, if I can call it that, and therefore we are contingent on our ability to sense the environment and get that information processed and then pass to the next node within our network to make the decision and be able to take the next action. So I don't know if you guys have anything to add to that.
No, well summed.
All right, yeah. Classification is an issue, right? So maybe God knows in the end, I don't know.
Right.
Okay. Tatum, what makes activity-based intelligence a game changer, and what gaps in data integration are we still struggling with?
Yeah, great question. So thinking about activity-based intelligence, I went back to a little bit of history, and it turns out actually next Friday is the 70th anniversary of the first flight of the U-2, probably one of the most prolific ISR platforms, in our generation. And fun fact for those that like fun historical facts, the first flight was unintentional. They were just doing a taxi test, and the U-2, with its giant wingspan, managed to take flight at about 70 knots, about half the speed of what a traditional airliner would need, by accident. And the pilot struggled to get it back on the ground in one piece, but managed to do so. And it had its real first flight as scheduled a couple days later. But ever since then, sensors have continued to improve in their ability to get different phenomenologies, the volume of data that they collect. The NRO has announced in the next couple of years they're going to be collecting 10 times the amount of data that they do today, right? That's a huge advantage in terms of our ability to glean situational awareness, but it comes at the cost of needing good algorithms, AI, ML, and the transport of all that data to get to the right place at the right time in order to make those decisions. So as far as gaps, I think we've hit on them right already in this panel, and you've heard about it throughout the day. Classification is one, standards is one, right? If I'm putting it out in one format and you're putting it out in another, it's going to be difficult for anything to be able to fuse that and get any useful information. When it comes to fighting at the secret level, absolutely agree, and increasingly we've heard stories out of Ukraine right at the yes foreign level. How do I make sure that the data can be shared with our foreign partners and still protecting the sensitive sources and methods that we need to, right? So those are all challenges, but I think the industrial base and our non-traditional partners, all across the U.S. technology sector are well prepared, and I think we're on the precipice of making some great things happen.
Excellent. Any follow-ups? If not, Paul, I'm coming to you. And being a multi-domain guy, all of you guys are, but you love it. When we talk about multi-domain integration, what are the real architectural barriers preventing seamless coordination across air, space, sea, terrestrial, and cyber?
Yeah, great question. So I'm going to double down on some of the comments you've heard from my fellow panelists as well as earlier in the day. We can't think of things as a singular architecture. We have to change the mindset and start thinking about systems of systems architecture. And so when we do the acquisition, it can no longer be focused just down and in, but we have to think about up and out. And how are we going to bring forth capability? Not a single platform mindset, but not acquiring a single system, but rather how are we acquiring capabilities? So to enable that, we've hit on one of the big challenges right now is we have disparate systems on disparate networks. They're not connected. So let's get them connected. And I think through adoption of commercial technologies, particularly hosting applications in the cloud, we're seeing that bear a lot of fruit. But then the next step, which you've also heard, is how do we then adopt a common lexicon to exchange information, to enable machine-to-machine exchanges of data, which means using a common vernacular through open standards. And on the open standards, let's come to agreement on what they should be. And can we work together, endeavor across these domains to improve those standards? So ensure that we're all able to use the same vernacular, have the same interpretation. So that's my other key point here is we need the data governance. So that we're interpreting the data the same way, but also be able to release that data. And so the emphasis for a lot of these new and emerging capabilities that's shaping the architecture is more of a focus on machine-to-machine data exchanges, just because as we look at how warfare is evolving, in particular, being challenged with peers, the theater is measured in tens of thousands of square miles, right? So it's not a localized conflict, but these potentially could span huge areas with multiple coordinated and synchronized planning that has to occur. So with that, I'll say the last note on that is, for the ramifications on an architecture, we need to be quicker in adopting open standards and also be more adept at adopting commercial technologies that enable the seamless integration and flow of data. All right?
Excellent. Okay, now I have one for the group, so feel free to answer. What's the biggest misconception about what it takes to close the kill chain in today's environment?
You push a button and something happens. Push a button and it goes boom. It seems like there's this pervasive belief that it already works. I mean, I certainly feel that when my leadership comes and says, here, Jared, go make this happen. I'm like, sir, I'm an engineer. Let's talk through this. Not everything is connected yet. We need it to be. It's not all integrated. And we especially see this as we look at commercial integration. There are great technologies coming online. Those technologies work in the environment in which they're developed. Those technologies have promise when it comes to our larger architecture, but I still need to get them connected. I still need to get them integrated. And that takes time, that takes funding, that takes resources. And it's competitive trying to bring all of that together. And I think that's one of the misconceptions I see is that, well, it just works, right? I dial a number, talk to my family on the other side of the world.
Yeah, one that I've seen and heard about recently, especially, is AI is going to solve it all, right? We'll just throw some AI at it; it'll be good. And what we found is, if you're training an AI, it's only as good as the data that it's trained against, right? And it's only as good as the simulations that it can play against. If you've watched war games, right, you need the red player that's going against it so that it can determine the right course. And to that end, Lockheed, I think that there's a talk tomorrow about our AI Fight Club initiative, which we're starting out to take all the synthetic environments that we've built for our joint all-domain command and control and let commercial companies come in and startups and defense contractors and whoever with their great AI algorithms and let them play against each other and see which one prevails, right? And then start throwing, all right, we start you in a benign environment, and then we start ramping up the environmental things, right? Weather changes, electromagnetic environment changes, those kind of things, and see how those algorithms can adapt and where they need to be taken back and updated in the factory.
Yeah, and I'm going to capitalize off your comments. Believe that one of the misconceptions is that it's easy. We hit that. But when you think about fundamentally, how do you test realistically? And then how do you train? How are you going to train like you fight at the scale and magnitude required for these systems of systems? Because it does become very complex. And so how do you inject noise into the system like what we would expect in real engagement? So those are challenges that we try to work together collectively, recognizing that we have to work jointly to get after these problems.
Excellent. Okay. So now we're going to go part 2, where we're going to talk about how
Next level.
next level, right? So the next level, how are we bringing?
Come faster.
Yes. Well, it's how do advanced technologies play a role, and how do we start to bring them in to close those kill chains? So we're going to discuss how technologies and frameworks are changing the game, from mesh networking to edge analytics to AI, and how we're going to use these to advance ourselves to that next level. So Tatum, you're up first in this round. Come right up your alley. How is AI being used to enable faster, more accurate tasking and targeting? And can you offer a real-world use case?
Yeah, and I had to do some studying to make sure I didn't stay on the right side of security for the real-world use case. But the one that came to mind was the recent Red Sea activities. I think many have heard in the news about the Navy's challenges operating in the Red Sea. And the time that was quoted by the Navy was they basically had 60 seconds to make a decision, right? Is it a threat, and how am I going to engage that threat? Is it coming after me? And our team, Lockheed Martin team in Moorestown, was able to work with the Navy, get some AI algorithms deployed out to the ships to help them sift through that noise. And the really important part was they worked closely to figure out how they could rapidly inject small changes to the baseline, the Aegis weapon system baseline, and do it on a very regular basis, so that we weren't waiting for a full-on formal test cycle and all of the rigor that goes with that, right? For small changes that are low risk to the overall system that you need in order to make a better decision, allowing that to go faster. And to me, that's an opportunity that we've seen pieces of it in this space arena, but I think there's opportunity to lean more into, how do we get more rapid with our acquisitions on the hardware side, on the software side? How do we bring them together in test ranges? And how do we iterate in solving those problems?
Excellent. Okay. Paul, what advancements are you seeing in the integration of legacy platforms and new systems into a common operational picture?
Yeah, so briefly mentioned that the adoption of a lot of commercial technologies, including hosting legacy enterprise ground systems, for example, into cloud environments, but also with the development of data fabrics, so that we're exposing data, able to put in place the cross-domain solutions that allow greater connectivity between new systems and legacy systems. So that's the software side. On the platform side, there's a lot of work being done as well on leveraging, for example, what we call the beyond line of sight communications. So there's a lot of investments being made on getting the joint force connected through space-based networks. And that opens up a whole new realm of situational awareness for our air crews, as they're in operations, being able to ingest data in near real time and truly have, for the first time, a joint common operating picture. Had mentioned earlier, the adoption of standards. With that, there's also great, what I'll say, design patterns that we borrow from commercial industry. There's a lot of technologies out there that allow for the seamless data translation between one format to another. So being able to adopt those types of technologies, because it's not always about acquiring a new system. And I think you've all heard the cliche, you go to war with the army you got, not the one you want. And so how do we leverage and harness some of those commercial technologies to better squeeze out more military utility out of our existing systems?
And I'd like to riff off that, if I may. Because you talk about how do we bring those technologies in? What is the best way that we bring it in? And there's been other forums here today, and you saw it in the video, the digital engineering environment. SSIO is championing that. We're working with the PEO, organize OTTI, Operations, Test, Training, and Integration. If I said that right. It's like math in public. But the digital environment, I think, is one of the areas where we're going to collaborate more tightly and allow our industry partners to bring solutions, tease out the ways in which we're able to find the ways in which they plug in best, right? And then we can also tease out where those standards need to be established to get the interfaces more tightly coupled between the capabilities.
All right. So Jared, we're going to come back to you. How are we addressing secure and resilient communications in contested environments to ensure data reaches the decision makers in a timely fashion?
Well, we're dealing with security. Best security is you don't tell anybody. We don't want that. When it comes to decision or data to decision, I spoke about we've got to be able to close from where the data is collected to where it's actually used, where the sense is made, and where the decision is made. And so you've got the ground networks, Mesh 1T going out, being proliferated. Mesh 1T is our ground program, and then there's initiatives like MilNet that's caught up in a little bit of a setback right now, but the service is working through trying to figure out that architecture and kind of try to, as part of our PLEO, really is what it is, and ensure that we have interoperability between providers and connect the space layer and the ground layer so that we can get that data securely and assuredly from source to consumption.
Excellent. Okay. So we're going to have two group questions in this session here. First one, and this one's probably going to have a good discussion associated with it. What role do digital twins, synthetic environments, and simulation play in testing and accelerating data to decision workflows?
Should I rewind the tape here?
Well, but
I said
I'm going to add a little. What type of environments do we need to make this work?
Common environment. I mean, that's been the challenge, right? What is that environment? I talked about security earlier. We have models at the secret level. We have models at the SCI level. We have models at the SAP level. And I have engineers operating in teams at those different levels. Well, I need to be able to have an environment that can send the design information up and down. I need ways in which we can send data, simulate data, so that as we're designing the architecture, but then once we go from concept to design, develop, deliver, field, then be able to send that data across those classification levels. And it's not all data, right? We think in the age of AI, it's quantity and availability. But the reality is you need the right data at the right node. And being able to have that data, a data house like our unified data library that can transit the data or store the data. And then as it's transiting, it goes from the source to where it needs to go. And then that right decision is made. So we're working on those architectures, those functional architectures, so that we know how, in the data layer, how that data will transit the network. But then we're also looking for solutions, ConEps. It's not a one entity or one group kind of knows everything. It really takes all of us understanding where you are in that chain and the thing that you're developing for that node in the chain. This is what I need to come in, and this is what's going to come out. And then how we interconnect there so that then that data gets routed appropriately.
I would just add there's lessons to be learned right from the commercial market in this place. I know last year I had a team that looked at some of the technologies that Facebook had built, Meta, and their challenge is trying to connect. They want to make sure that everything about you as an individual they know, so that they can feed you the right things to keep you clicking to the next article or the next piece. And they actually open source a lot of their technology. So they have a cross multimodal latent feature space alignment capability that basically allows you to take a piece of data from, say, sound or an image or a video and basically extract out what a neural net would do, the first level of learning, and then align those and then be able to recognize when you see the same thing in a different modality. So I can go from, I hear the sound, and now I can associate it with the video or the picture. And if I get one of the two, I know I can cross them. And applying those kind of technologies to the data lake in the environment where I have the high fidelity simulations where it can help us advance the capability much better.
You know, and I'm going to stay on the theme of train like you fight. So when we talk about cross-domain and multi-domain integration, these are complex systems of systems. And so to do joint exercises at the scale and magnitude that's really needed can be very cost prohibitive, very time consuming. So the better we are at creating these digital twins and these digital environments to provide that realism, the more crews that we can reach and train and start thinking about tactics development, start maturing what the joint warfighting capabilities are.
Okay, and then another one for the group. How are programs and platforms evolving to support machine speed decision making without sacrificing human judgment? So as we bring in AI, how do you make sure that human judgment's still being played and taken into account?
Asimov's rules. They solve it, right? I think through simulation, we talked about simulation, understanding what those functional node steps are in your kill chain. As long as you, well, not as long as, but provided that we've built our kill chain appropriately within the digital environment, so we understand each of those steps, and we work with our guardians to train like you fight. Thanks, Paul. That's a great concept there, because then that provides the feedback into that functional model, so that you say, you know, this is really taking us too long, and there's a lot of data that's starting to go into this functional step. Why don't we take and automate that and apply an automated decision support tool step for that? You know, legacy, it's like human every step, and you just go into the paper train. And we got to get out of that line of thinking. Even when we have technologies and capabilities today that could simplify some of our ground system processes, we tend to still throw guardians at the problem. And it's like, no, let's take a step back. Let's get comfortable with our digital twin. I guess that's another way we could use that. It's now becoming an inflated term. But our silicon counterpart, I think, I remember if one of you told me earlier today what a cool term for that automated assistant. But anyway, the idea there being that if we train with that, you train like you fight. Now I'm training with the computer that's doing some of that cognitive offload thinking for me. And then I understand, yes, I'm comfortable with it. Plus I know that that's something I can rely on and I can trust within the confines of the law of armed conflict, some of the other constraints that as a uniformed service member I'm bound to, so that I can still prosecute the adversary, but do more things faster, right?
Yeah, and we think of it, the last part of your question was about the human aspect of it, right? So it's all about, as you're applying AI, and AI leads to autonomous platforms, right? Those autonomous platforms have to have ethical limits to say, I'm going to give you autonomy to carry out a certain set of actions, but when you reach this decision point, you're going to have to pause and come back to a human. And we've seen that even on the integration of legacy platforms. Like, we've got Blackhawks now that are enabled for autonomous operations, right? It's a huge platform that can fly from one place to another, deliver cargo, but it's got to have safety checks to say, all right, at a certain point, you're going to hover and wait for a human to say it's okay to land, or whatever the next step is.
Yeah, and I think, you know, what we're seeing is really the evolution of command and control, where we'll still have centralized command, but decentralized control. And as part of that equation, part of that decentralized control maybe autonomous agents running on board, operating within very well-defined parameters. So in that model of a centralized command and decentralized control, many of you probably heard the phrase human on the loop instead of a human in the loop, and really being able to provide the operators the tools they need as decision aids. But then once those decision aids are in place to select the best courses of action, be able to execute through autonomous systems, recognizing that we will be operating in contested environments, but we still need to ensure that we're exercising responsible and authoritative command of those assets.
Okay, thank you. So we're going to move into part 3, which is the future. Okay, what do we need to do to build smarter, faster, and more efficient kill chains? Right. So this is thinking about what's the next steps. So Paul, in this session, you're going up first. How will space-based sensing and on-orbit processing change the game for multi-domain operations?
Absolutely. So, I think most folks recognize that space provides unparalleled access and coverage. But how things are evolving and changing and where we see the need for greater onboard processing is being able to better support tighter, what we call OODA loops, the observe, orient, decide, and act. And a lot of that is to support the joint fight, things like time-sensitive targeting or target recognition, target ID. And we need that to be done reliably, and we need to do it in tactically relevant timelines at a scale and magnitude that is over at a theater level. So again, think of a very large battle space. I think we all recognize the value, particularly that space systems bring to the kill chain, what we call find, fix, track, target, engage, and assess. And the data that subsequently flows through those aerial networks who are relying on space as the backbone for that. So like other domains, whether it's air, sea, land, subsurface, cyber, we also need to be prepared to operate in contested environments. And as part of that, you need to be able to process what you sense, and as we start adopting more artificial intelligence on board autonomous systems, including space systems, you need more onboard processing so that we're able to put processing at the edge, make decisions at the edge, and then get it to the warfighter in time-critical timelines.
All right. Jared, this is something we talk about a lot.
My favorite subject.
It is. How are new acquisitions and doctrine evolving to prioritize speed, interoperability, and resilience across the kill chain?
So it's interesting. Traditionally, we have bought a satellite, and then along with it comes the link segment, the ground segment. You deploy that, and they become a unit. They operate, they provide services. Now that we're in a warfighting domain, we got to bring all that together as a C2, right? The command and control that Paul, you talked about. That's the nexus of what we do now with space operations, is this federated environment in which all of our ground systems are connected together, and not just for Space Force systems, but also our mission partners with MDA, with NRO that are operating in space for national security space. And how do you communicate with them? How do you put them on a common lexicon, on a common schedule, an integrated master schedule, a common kind of program plan, without perturbing things that they need to do with their individual priorities and individual funding streams, but still also contributing to the collective whole? And so we came up with this concept called increments. Fancy name, right? Increment 1, increment 2, increment 3. No, these increments that deliver by year, in which we're able to, even within the context of when things are delivering with their own acquisition schedules, provide an integrated assessment in which I can run an end-to-end test. And I can look at hey, what's good enough? At what point am I able to exercise this capability, this system, within the system of systems, so that my guardians get experience with it, they can provide feedback, and we can update the requirements for the interfaces between them so that the kill chain works as a whole. And so that's an integrated assessment that then SSIO leads in conjunction with our STAR Command, Space Test and Training and Readiness Command, and our Space Operations Command, who has the responsibility for delivering to our ultimate customers the components. Okay, so that we can then advise the SPOC and the Space Forces for Space, or Space Forces Indo-PACOM. You have a capability coming online. This is how much we can provide today. The objective system won't be available till sometime in the future, but let's not continue to look and anticipate, but let's see what we can do today. And in some cases, we anticipate that as we go through this integrated assessment process, that we will learn some assumptions about what we needed to close the kill chain for that objective capability may not be as exquisite as we wanted. The guardians may be able to say, you know what, at this node, I talked to those functional steps in the kill chain, at this node, I can do a chat window, I can do a phone call, I can run a letter, I can send a letter, send, classification, go between systems, burn a CD, run between halls. It's funny how we still fight sometimes like we did in the earlier wars. Send runners, because it's the best you got. Write it down on paper, use a whiteboard, right? Our guardians are going to make it happen, okay? And I can't be prouder of the ways in which they're executing and the mission. But when we have that feedback, then I can say, look, this node that was looking for the exquisite system doesn't have to be that exquisite. We proved it through an exercise or through a test and demonstration. And therefore, let's shift the requirement, let's shift the funding and resources to solve another hard problem, but still getting the kill chain. And that's kind of like our agreement with the combatant command commander that has said, I need to know when you're delivering and what you're delivering. And we say, this is what we're delivering, this is how much you have now. And we will continue to evolve to those objective systems. And through the increments process, as we work with the SAE, it's not just for today, but we also have the plan for when we bring on new systems. As new concepts are thought about, new concepts need to be integrated, we can show at what point those become mature enough for us to do an integrated assessment and then to start building them up to become part of the operational capability. It's a huge thing. We've got 3 documents that we brought forward, a design reference mission that actually aggregates this stuff. We have an integrated roadmap that pieces together all of our contributing components, contributing programs. That's with the program data. We have the requirements, enterprise requirements, that hasn't been done before, right? Typically, you go through the JSIS process that had been talked about earlier today. There may be some changes there, but you get your requirements, you're locked to those requirements, you deliver to those requirements, you test against those requirements. You didn't meet that test to the letter, then it's like you fail, right? No, we're bringing that feedback in there and saying that you have a minimum viable capability. But Dave, what I want to highlight here is we have a culture shift. We have a culture shift within the acquisition. You and I have seen that. I think even you as our industry partners, as we've seen through our consortiums, we have a culture shift that says we need to do this together. It's not so much about the CDD. While the CDD is important, that is our edict. We must deliver against that. It is how are we doing this together? This program and the adjacent programs need to interface and deliver together. So it's a long answer, but like you said, it's our passion area.
It's beautiful, right? Because the way we've done requirements in the past may not be the way we do requirements in the future. So you bring up good points. As you start to think of systems, how do you bring it together? And is there better ways to do it and change the culture? So fantastic.
And if I can just add one, because I loved all the comments, and we heard about it from General Grant this morning, right? The number one thing is communication, and I've definitely seen a state shift in acquisitions in the last couple of years to where, now when the requirements come out or whatever the equivalent document is, right? The government is asking, and tell me if there's one of these that's going to drive cost and schedule. And if we tweak it a little, you're going to gain back that cost and schedule. Let's have a dialogue on it rather than just saying, nope, this is it. Tell me how you can meet it. And suddenly we come back with a proposal that the government says, no, that doesn't meet our costs. And we're like, well, if you had changed that one requirement, we could have made it, right? So we're having a much more healthy dialogue, I think, than we ever have in the past.
Excellent. Okay, Tatum, to you. What's your vision for fully integrated and enabled decision systems at the tactical edge? And then what is missing to make it real?
Yeah, sure. The fully enabled AI to the edge, I think it's about getting the right information into the hands of the decision maker on time, right? We've talked about it. So in the example of the Red Sea, right, it's closing that loop within the 60 seconds so that they know they're using the most appropriate munition to defeat that threat, right, and not setting themselves up for challenges later on in the campaign. We talk about the need for standards and APIs and how do we iterate faster along those lines, and how do we make sure that whatever we're testing works great in a lab, works great in even a synthetic environment, but how do we know that it's going to work in a contested environment, and are we sure that the lab is throwing everything that it can at all of those algorithms to get there? And all of this is necessary, right? It was encouraging to hear Dr. Hammett say maybe there'll be some emerging changes to cybersecurity policy when it comes to AI, because that is a challenge, right? We can only move as fast as cybersecurity and security will allow us. And a lot of times as software developers and leaders of software developers, it is often that my developers will come and, man, the best piece of code is right there and it solves the problem. But the number one contributor is not from a good place, so we're not going to be able to get that into the system. And we're working through that, and I'm encouraged to hear some movement along those lines. And all of this is necessary. We've got to get to that, defeat the spectrum of bad stuff that's out there, so I think we'll get there.
Excellent. Okay, and this one's to the group, open one. What role will, and Jared, you alluded to this, and we've had several discussions about this, what role will cross-industry partnerships play a role in delivering the capabilities at speed and at scale?
Dave, space is competitive. It's competitive on all fronts. We think of it competitive in the threat environment, but it's competitive at home too. I don't have enough people. I don't have enough money, right? And there's a lot of talent out there that is competing to survive. Okay, so in this competitive environment, it's incumbent on us to find ways in which we can come together as a government-industry partnership, industry to industry, as well, to find those solutions that will solve those toughest of problems in space. Have we identified all the problems in space? No. No, there's more problems. There's more problems than we have time to solve. But we need to get after the right problems, and we do that together. I think that's how we do this, why the industry-government partnership is so important in finding new avenues to strengthen those relationships.
And I'll say that the adoption of consortiums has really enabled different companies within industry working with FFRDCs and the SPOs to really have, I'll say, diversity of thought and allow us to start getting after the problems together, because these are really hard problems, very complex when we start thinking about systems of systems. And in particular, how we start thinking about how does my platform work with yours, and really trying to maximize the military utility that alone we don't realize, but when we start aggressively sharing information and getting after problems, let's say multi-int, and combining things in ways that maybe we didn't originally think of. What we're seeing is game changers, force multipliers, and because these are such complex problems, and the only way we're going to get after it is if we're able to aggressively share at our levels.
Yeah, I'd say it's definitely going to take a whole of industry approach, and I think we've seen acquisitions come out to encourage that, things like consortiums, things like awarding to multiple awardees and encouraging collaboration so that we can pick, if we're picking a common supplier, right, we can all make sure the supplier is going to meet the schedule and timelines that we need and the requirements for performance, and all of that comes together, I think, with the sweet spot that we're starting to get much better at leveraging, but I think there's ways to go, is how do we bring in technology from the commercial industry, from non-traditionals that have solved problems in other ways, and adapt them to the unique environments that we have here in space.
And I'll just follow it up. We're part of a Fight Tonight consortium, which really is looking at closing these near-term gaps to kill chains, right? So all the time what we're trying to do is, as SSIO finds gaps in these kill chains, how we work with the operational test and training community to prioritize those, and then what can industry bring to the table to close those so that we really are ready to, if the fight were to happen tonight, we're ready to go. So it's a pleasure working with these guys. I know everyone up here is passionate about this. Paul can talk to you for hours about this. So, okay. So now we go to the lightning round. We're in the last closing stages here. So I want to ask each one of you to any last words you want to have before we go to the question and answer session of this panel.
Thank you. So I think the one thing I hope folks take away from this dialogue is a recognition that to really enable joint warfighter interoperability and be able to compete and be prepared for the challenges that we face, we need to break out of the mold of myopically focus on a single system, but start looking at the systems of systems. How do we transcend domains? So a phrase that we like to use is, as in the air domain, can I have space as my wingman? And let the message exchange flow in time-critical time to meet those time-sensitive targeting requirements. So that there's immense amount of challenge, and it is going to take everyone working collaboratively together.
Yeah, completely agree. I think it's about that end-to-end. We talk kill chains. That really implies end-to-end. I've got to go from sensor to shooter. I've got to go from in raw intelligence to a decision. And I think that's more and more as contractors on the contractor side, as government, stop thinking about your system in just its little space in a myopic view, as Paul said, and look at it as what is the end mission objective? What's the military utility that I'm going to have? And how can I benefit off of another platform from another vendor? How can I benefit off of another piece of intelligence that I maybe am not already ingesting, and ultimately bring that together?
And I'll just follow it up. I heard it best when Rear Admiral from one of the Navy program offices said, we deliver at the speed of integration. Bureaucracy is going to get in our way. We've got to integrate on so many different fronts. But to achieve our mission of security into and through space, it's an all hands on deck. And we need all talents, all career fields, all capabilities to be able to pull us through to the future of space, especially with the growth of the space market. There's so many opportunities here for folks to get involved on the industry side, and we need more teaming. We talked about that earlier, and the collaboration is really what's going to allow us to maintain that competitive edge, so that those of us who have loved ones in harm's way, that they have more assurances that they will make it home, and that we will maintain our security and our way of life.
Okay. Now we have question and answer, and we're late in the day, but the crowd brung it here, so there's some good questions here. So first one, again, right, there's always risk. If we talk about integration and bringing everything together, there's going to be risk. So first question, a connected system is more susceptible to cyber attacks. So as we increase integration, how do we ensure that we are staying secure?
Don't tell anybody about it.
Well, I'll take a first stab at it, and then feel free to pile on. But so that's a great question. So we have to assume, that as we get connected, that those connections always need to be evaluated, continuously evaluated. So we talk a lot about zero trust and being able to use innovative applications, leveraging AI, for example, to determine has something been compromised, and then how do you roll back any information that may have come back from that compromised source. So it's a very challenging problem. I would be mischaracterizing it if I said there's an easy solution, but there is a lot of investment being done between government, including labs, industry, and especially commercial industry, who a lot of businesses rely on business-to-business transactions and are equally impacted by these same types of threats and attacks. So I'll just say that for now, just assume that as we connect the nodes, that there has to be a model of zero trust and continuous monitoring.
And I'll add to that, I want to thank AIAA for hosting this conference where we can come together and talk about these challenges. Yesterday's panel on zero trust was really good. I liked one statement there that said, you just start with assuming you're vulnerable, assume that your risk, assume that your threat is probably already there, whether it's inside or external. And then the zero trust technologies that are coming online is that pathway.
Yeah.
Okay. All right, so we're going to build on the commercial. You brought that up, Paul. So commercial solutions typically don't have the same resilience or reliability as defense designs. For example, radiation-hardened electronics. Aside from pure proliferation, what strategies are being used by the DoD to ensure broad reliability with the integration of commercial and traditional solutions?
That's a very wide question. I can at least do the narrow piece of it. Within our business area and within Lockheed Martin Space, we get occasional ideas. Our missiles and fire control brethren will come and say, "Man, we got this really cool sensor. We've managed to shrink its footprint and its power requirements, and we really think you could use it in space." And to be perfectly frank, we don't know how it's going to handle a radiation environment. So our recent approach is, all right, well, let's just fly it and we'll see how it works. So, along that. Experiment faster, iterate faster, right? We're gonna send some experimental payloads up on our internal investment satellites, and we're gonna see how they perform, right? Oftentimes, you may assume commercial products are gonna fail in space just because you've never tried it. So let's try it, see how it works.
Fail fast.
Fail fast.
Learn much.
And learn. Learn when you do fail.
Exactly.
Right.
It's only a failure if you don't learn, right? Okay. How can advanced computing, edge, quantum computing, some of these things that are coming around, improve decision-making across the end-to-end multi-domain operations?
So, we hit on it a little earlier on building a true COP, a common operating picture. And, instead of each individual node sucking up trons and sending it back to a central, which is going to take a horrendous amount of bandwidth that may not be available, you need that computing to leverage the collection and exploitation at the edge. Because it's not always the data, right, that we want. It's the information derived from that. So classic cases, when we talk about things like your ability to track entities, I don't necessarily need your raw image or raw data, whatever it may be. But if you're able to process that and give me what we call the PPLI data, the precise position location information, that's what I really need. And now think about doing that at scale. where you have hundreds of collectors out there, and we're able to bring it all together, and through the power of AI, be able to correlate, fuse, to create a true common operating picture. That's how we get after the problem.
Yeah, and I'd add, in the space domain, we need to think about, and how do we rapidly evolve it, right? So if I have compute on the edge and I've got my algorithms deployed, how can I update them on a frequent basis? And that's going to require a little bit of lean in on the test community to say, all right, I'm going to upload this to the vehicle, and it's going to become part of the onboard payload processing. Is everybody okay with that? And have the safety barriers in place to be able to roll it back if something goes wrong.
And I think on the training front, the advanced computing is providing opportunities for us to create the common environment that I can test and then operate in. Right? You may partition the two because you want to protect your operations from critical failure, but being able to bring the Guardians in on the same environment with live data, that's the live constructed virtual environment, that then they see the exact same terminal, as it's going in development with that feedback process I was talking about, for making sure that we're delivering what they need, then they train on it, and then they operate on it. And you go back through this. The reality is you can't really do that type of environment through a laptop. You can't even do it through your most advanced Mac. You need a much more high performance computing capability that will allow us to extend and get to that common operating environment that transcends each of the phases of preparation.
Okay. Well, we're at the end of our time, and there's some good questions on here.
47 seconds.
Oh, yeah.
Not for the fastball.
Second answers, no.
Lightning round.
First off, I want to thank you gentlemen for being on the panel. I work with you guys a lot, and it's a pleasure to work with you and to talk about this subject. I think we're all it's near and dear to our hearts, and I appreciate everybody in the crowd who was able to make this session at the end of the day. So with that, thanks, everybody.
Thank you.